Okay, so we're going to talk about the rule of the log, okay? Property of the log, like very, very similar with this. So here is the two parts. It's the one of them is the exponent, and then one of them is the log. So the a to the x, the a to the y is equal to what? You're adding the exponent, and then when you have a quotient, division, and then you have, subtraction. And then if you have like two exponents next to each other, and then you have the multiplication. But in the log, it's the same idea. If you have like x and y, then you have to adding up, right? Okay, so just remember this. If you have a quotient, then you have to subtract. But when you have exponent on the log, right there, the y is you can bring to the front, and then log base ax, right? So I'm gonna prove to you why this statement, this formula is true. So log base axy is equal to log base ax plus log base ay. So I'm going to do let m is the log base ax, and then n is the log base ay. And then we can change. Last week we learned about log definition, right? So if we have a log equation, then we can change the log, the exponential. The exponential equation is a to the m is equal to x, and then that one is a to the n, that is equal to 1. So this is the log equation to the exponential equation. So let's change that. And then we're going to multiply this together like this. That means is you're going to get a to the what? The m plus n equal to xy. Xy. So this is the what? Exponential equation. And then now let's change to the log equation. So that means is m plus n is equal to log base a xy. So that means it's log base a at the xy is the what? Log ax plus log ay. Check. Right. Because m is, oops, sorry, m is this, right? So that's why we got here. And then n is this. So that's why it's here. So same idea with this. When you have a quotient, let m is the log ay, x, right? And the n is the log base ay. So change the exponential equation. So it'll be a to the m equal to x. This is a to the n equal to y. So now this is quotient, so we're gonna divide, okay? So we're gonna do division. So this is talking about a to the m minus n equal to x over y. Then now you can change the log equation, right? So we can change that. And then now we can set it up. M is this, and then that is this. So that's why equal to x over y. So if you know how to do the log definition, and then I think you can prove you can have proof for the addition and the subtraction of the log. Okay. But anyway, so let's play with this. So if you have a log base 5, z is 3, and then log base 5, y is 2. And then you have to evaluate each expression. So log base 5, y, and z, it means multiplication is addition. Like that, right? So log base 5y is 2, and then z is 3, so that's why the answer is what? It's 5. What about 125y to the 7 power? 125 and the y to the 7 is a two separate part. We can do the addition, and then we can play with what? The exponent. 125 is the what? 5 cube. So we have a two exponent, which is 3 and 7. This 3 and 7, we can what? Can you see that? This one? The y exponent we can bring to the front, right? So that's why 3 times log base 5, 5. Oops, 7 and y. So now 3 and 7 is in the front. So what is the value of a log base 5, 5? This one is what? Is 1, isn't it? And then log base 5y is 2. This is 2. So actually they're asking about 3 times 1 plus 7 times 2, which is 17. Make sense? What is the power of square root? The power of square root is, what is the power of square root? Nobody knows? 1 over 2. Exponent divided by index. Square, and then this is the 1 power, right? So exponent divided by index. Blue divided by green. Always, okay? That's why it's the 1 over 2. And then bring 1 over 2 in the front because it's the exponent. And then since this is division, z divided by y, you can what? subtract with parentheses. So don't forget the parentheses. Then you guys know what is the log base 5z and y. So that is the 2 and no, 3 and 2. So that's why this is what? 1/2 is yes. Okay. Easy. What about letter D? Same thing. Wow. Log base 5, z raised to 1/30 plus y to the 5th. So 1/30 is exponent. So and then 5 is exponent. Like that. And then log z and log 5 is 3 and 2. So that's why this is the 1/10 plus 10, which is what? 101/10. Or you can say 10.1, either one. Right? 100 plus 1, yeah. 101, yeah. 101, yeah. Or 10.1, either one. And you can answer to the fraction or decimal. So you're gonna see this on your homework. Okay? It's pretty easy to do. How about the opposite? So we have a single log here, only one log, and then you're gonna expand it. Okay, expanded form. Expanded form means is you're gonna have multiple of log. Okay, you're gonna have only like you're gonna have like maybe 3 log or 4, maybe on this case 3 maybe. But anyway, if you have a division, it means it's a subtraction. So that's why first step, I'm gonna split up on the top minus and then the bottom. So in the beginning, we have only 1 log, but now the first step, you're gonna have 2 log right there. And then I'm gonna highlight green, this part, because this is the multiplication of x squared and the x minus 1 cube. This one we can split up by 2, right? Because it's the multiplication. So this one is also what? And then the last term is just copy down like that. So now we have 3 log. And my question is, are we done? No, because we have property right there. Any exponent bring to the front. Okay? So we don't need any square or cube or fourth power. I'm gonna highlight blue, this part. I'm gonna bring to the front, and then we're done. Okay? Like this. 2 log base 2x, and then 3 log base 2 x minus 1, minus 4 log base 2, and then 2x plus 1. This is the final answer. So expanded form means is you're gonna get longer, okay? Multiple of log. Any other question? What about square root? One other one. I said the power of square root is what? 1/2, okay? And this one is gonna be 1/2. I'm gonna bring to the front. And then like that. Because of the power of the square root is 1/2, so that's why 1/2 now is in the front. But the problem is this. We have a bunch of the multiplication. X, Y, and Z is different exponent with the multiplication. So multiplication means is what? Addition. What do you think about this part? What is missing? It's wrong, actually. This is wrong. If you do that, oh, I'm done, it's wrong. What is missing? I know it's the exponent. Yeah, exponent we have to bring to the front. I know that, but not exponent. Which one is missing? Nobody knows? I know today is Monday, but parentheses is the key. Okay, so don't forget parentheses. The 1/2 times the log, right? But that log has x, y, and z, not only x, it's not only y, right? You know what I'm talking about? X and y and z is multiplied by what? 1/2. So that's why we have to multiply, we have to do what? Put the parentheses. And then you're gonna see the another story, okay? Y, here is y. So now all the exponent bring to the front. So 3 log base cx plus 2 log base cy and plus 5 log base cz. And then we have to distribute them 1/2 for each term on where? On the coefficient, right? The coefficient on the number, right? Right there. So 1/2 times 3 and then 2 and 5. Okay. Then this is going to be the final answer. So 3/2 log base cx, and then 2/2 is 1. Okay, so 1 log base cy, right? 2/2 is 1, right? And then 5 times 1/2 is 5/2. So that is the final answer. I mean, you can write down 1. I mean, or without 1, up to you. But it's going to be the same. So this is called expanded form. Okay, we're going to make a multiple of log. So don't forget the parentheses on that. Okay. Question? All right, then next example, may I? It's gonna be, we have multiple of log, right? We have 3 log, and then you have to answer to the what? Only single, okay? Only single log, okay? So any number, I think, in the front of the log is gonna be what? Exponent. So 2 goes to the exponent. So now is 5 squared. So 5 squared is 25. And then now I'm going to focus on this part only, the first two, because it's the what? Addition means is what? Is the multiplication, right? On the log. So that's why we can have log base 2, 25, oops, times 9. So 25 times 9 is what? 225? Then now we have a subtraction with 225 and 75 with the log. So subtraction is what? Division. So this one is pretty easy, right? 225 divided by 75, which is 3 with the base 2. The log base 2, 3. So the final answer is log base 2, 3. Okay. Question. What about letter B? I like this example. 1/3 and then bracket, parentheses, and then ln x plus ln x plus 1, and then another ln x squared plus 1 with a minus. So first, let's do the in the parentheses first. How about that? In the parentheses, I'm going to start with this 2. Only plus ln x plus ln x plus 1. It means it's the multiplication. And then like that. So x and then x plus 1, I'm going to combine together. And then let's do this. So this one is going to be x squared plus x, isn't it? X times x times 1. So actually it's the ln x squared plus 1. And then now let's do the subtraction. Subtraction means is the what? Division. Oops. Like that. So x squared plus 1 is on the top, and then x squared plus 1 now is on the bottom, because that means it's a subtraction. Look at that. And then from now is very important. What is the power of square root? It's the 1/2. Can you see that? But now is we have 1/3, right? Why? Because this one is the exponent. 2 is index. Index means is the next to the what? The root, okay? So it means is this is index. So how many root? Third root. And then how many exponent? Only 1. So that's why this is gonna be third root of, I know this looks very nasty, but with 1 power. That is the 1/3. So that is just third root of, oops, sorry, this is x. Square plus x. So one exponent is just, you don't have to worry about that, right? So third, so don't forget the third, okay? Third root of ln and then x squared plus x all over x plus 1. Good. Question? Okay, change the base of the log is pretty easy. Very easy. So x and y, x and b, right? That is just log x and then log b, right? So what is the base of the log? Because it doesn't mention anything, that means it's 10, right? And then what is the base of ln? It's the e, right? I think this is what we learned. So the log, so you have to change letter A is the common log, which is the base 10. And then natural log is base is e. So log 5, 13. So A is the log 13 over log 5, right? And then you can put that in your calculator, then you're gonna get 1.59369. Natural log is just ln 13 over ln 5. This one is also, you can put that in your calculator, right? So ln 13 divided by ln 5 on your calculator, and then you're gonna get same thing, same value. Okay, so this is the change of base of the log. Okay, with the common log is the base 10, and then natural log is the base e. Okay, so you can do two different way to answer. Okay. So let's do kind of application, like word problem. So applying the log to the growth and the decay. So the exponential form is, I know the notation is a little bit weird, but a of t is equal to a0 e raised to the kt, right? That is the exponential form. And then now you can change to the log form with ln. Do you know what it is going on? I mean, you don't have to write down, but if you would like to see, first, I'm going to put the ln. And then this one is going to be ln a of t, and then kt, ln ao, right? And then we can divide it by ln ao, right? So that means is you're going to get what? This one. And then that one is this, right? Because this is cross out. So that's why log form is ln a of t divided by ao, right? A0 is equal to the kt. And then what is half-life formula? Because we're going to do the half-life. Half-life formula is h is equal to the negative ln 2 divided by k. K is must be less than 0 because it's exponential decay. Okay, so you have to look at the example here. In the experiment, okay, the 18 grams of the radioactive, the element, the sodium 24 decay to 6 gram in 24 hours, and then find the half-life. Okay, this is what I'm talking about. First step is this. I know it's very weird. What is the half-life and what is the radioactive or that? Just focus on the formula, okay? Then it'll be easy. First step is this, okay? Ready? The ln, we have to use this formula. This is the log form. from the growth and decay formula, right? And then 6. So A of t is the final amount, right? And the A of 0 is what? Initial amount, right? Where you start, okay? So you start at 18 grams, right? And the ending with what? 6 grams. You got it? So A0 is the initial, where you start. A of t is ending, okay? Final amount. So that's why 6, sorry. They're ending with the 6 gram, right? And then they start at what? 18 grams, right? You guys follow me? With, we don't know what is K, but we know T. T is the time, 24 hours. So we can solve for T. So first, we have to solve for T. So ln 1/3 equal to 24K. So K is, I know it's going to be looks weird, but ln 1/3 divided by 24. So this is K. But K is not half-life, right? Half-life is what? It's H, right there. H is half-life. Well, we know K right there. That's why we have to start with the K. And then we have to plug in this one. Minus ln 2 over, bring that. Then give us H. Then now I'm going to show you how to plug in the calculator. Okay. It's not hard, but it's a little bit complicated, right? It looks like. So negative ln 2. This is easy to do, right? And then divide by, okay? When you plug in ln 1/3 divided by 24, you must put the what? The parentheses, this one, okay? On your calculator, so like this. And then 1/3, and then divided by 24. And then double parentheses, like that, okay? All right, I think you better write down on that, if you know how to do it, but. And then you're gonna get 15 points, something like that. What? Oh, one parenthesis. Yep. 15.142. Yep. So this one is about 15, oops, 0.14231. Yep. So nearest hour from here, there is 15 hours. Is that finer? Okay, so start with K, find the K value, and then plug into the half-life, okay, formula. And then the relationship between the A of t and A of 0 is A of 0 is where you start, and then A of t is the final amount, okay? Then that'll be, everything is gonna be easy, okay? All right, so let's talk about practice problem. So the log base B is 3, is 1.099, and then base B 8 is 2.079, and find the log base B 24. So how do we do this? 24, we have to use 3 and 8. 3 and 8 and 24, as you can see, you can multiply, right? So multiplication, 3 and what? 8. 3 times 8 is 24. So the log base, so log base B 3 plus the log base B 8. You can rewrite it with addition. So 1.099, 2.079. That is what? 3.178. Next example is weird because the given number is only 1. Log base 5 is close to 0.7, and then you have to evaluate the log 200. But here's the hint. That is very wonderful hint. The 200 we can rewrite with 1,000 divided by 5. 1,000 divided by 5 is the 100. So 1,000 is the 10 cube. But the log without base means is the log is what? Base 10. So we can use this idea like this. Like that, isn't it? 1,000 means is the 10 cube. But remember, the base is what? Is 10. Base 10 is what? 1. So the answer is what? Exponent is 3. This one is 3. Minus 0.7. So that's why this is what? 2.3. So you're going to see this example. Okay? So third root, the exponent, the power of exponent, I mean, the power of the third root is the 1/3, right? One third. Okay, exponent divided by index. So exponent is 1, and then the index is 3, so that's why that. And then that one is also 1/3 log with, don't forget the parentheses, right? And then all the exponent, I'm gonna bring to the front. So this one is this right there. And then this one is, oh, not this one. This one. So we can use 1/3, 2 times 2, like that. So this is 19/3. You're gonna have that. Is it right? 4 plus 15, 19. So 19 times 1/3 is 19/3. Okay. What is this? Wow. All right. Division is subtraction. Okay. So first you have to do the division and then do the exponent. and then you're done. Okay. Okay. So all the exponent bring to the bottom. So first division first, and then do the exponent later. Okay. All the time. Exponent is it's gonna be at the end. Okay. So if you have a multiplication also, okay, addition first, and then move to your exponent, move to the front. Okay. So like number 5, this is what I'm talking about. The base b, x fourth, y cube, the z, right? So addition first, and then bring that 4, 3, oops. And then the last one is you don't have to do that. So like that. Yeah. Number 6 is subtraction. So this one is going to be very simple. This one divided by that, right? And then I think that's it. Any other question on front page? All right, so flip over. So 5/2 is exponent. Anything with the front number is, or fraction, that is exponents. Like that. But we're not done. With addition means is the what? Multiplication. But we can play with this 5/2. Can you see that? 5/2 means is what? Like I said, exponent divided by what? Index. So this is the square root of x to the fifth. So that means is my answer right there. So when you put that in square root, we don't write down the index, right? So the same as the second part, the number 8. You know what? Let's do inside first. So this one is bring to that exponent. So this is log 7 z y to the fourth, like that. And then bring to the square. Oh, this is 9, sorry. Well, like I said, exponent divided by index. So that's why this is ln 7 base 7, log 7. And then 9 root of z y to the fourth raised to 1. So that is just like that. This is 9. Sorry, 9. The next one is 3 and then 1/3. So this is x cubed and then 1/3. So this is the subtraction means is a division. So anything with a fraction of the exponent change to the what? Index, okay? The third root. Means it's ln x cubed. Number 10, we can evaluate without calculator, using calculator. So why? Because this one is going to be 81 is the third, 3 to the fourth power, 3 times 3 times 3 times 3. 9 times 9 is 81, so that's why 3 to the fourth. So then this one, if you have a log base b is equal to 1, right? So that's why this one is equal to 1. So come on. So that's why, which is also 1, right? 4 times 1 is 4, but also the base is also 4. So base 4 and 4 is equal to 1. Any question? So next example. Oh, sorry. Sorry. Next example is you have to remember this formula. This is the formula. So b raised to the log base bx, that is equal to x. So if you have the same base like this, then this one, x, is the answer, right? So first, I'm gonna focus on this one. Okay, 7 is stay there. Now it's 4 square, right? So any number before the log, that is exponent, right? So 4 square is a 16. 16 with a plus. It means 16 times 3, isn't it? So 4 square is 16, and then 3 goes that. Addition means it's the multiplication, right? So 16 times 3, which is 48. So as you can see, we can plug in that one, right? We can apply that. 7 and 7, same base. So that's why the answer is what? 48.